Welcome to Lokad Live. My name is Conor, I'm the Head of Communication here at Lokad, and I'm joined in studio by Lokad founder Joannes Vermorel. Today's topic, how AI can act as a standalone pilot for supply chain decision making. Feel free to submit your questions at any time in the YouTube chat, and we'll get to them in approximately 30-35 minutes. And with that, Joannes, AI pilots in supply chain. It occurs to me that this conversation is very much an extension of one that we had, I think, about 4 weeks ago, wherein we talked about the implications of AI on employment and the future of traditional jobs versus AI in supply chain. So before we get into the specifics of AI pilots, could you give, for anyone who didn't see that, could you give a refresher, just an executive summary, what is our perspective on traditional jobs via AI in supply chain?
So the refresher is that there has been, I would say, a landmark achieved pretty much in 2023. Although it has been, this landmark is generative AI and more specifically LLMs, large language models. In terms of pure research, it's just a continuation of almost like 4 or 5 decades of continuous improvement in machine learning. So if you look at this from, I would say, a research perspective, 2023 is just a year like the others, with a long, and it's a long sequence of progress, and there has been, relatively fast-paced progress for the last 2 decades. Now, 2023, we have what comes to the market is packaged generative AIs for image and more importantly for text. And there is one product that popularized that, it's ChatGPT by OpenAI. And what does that mean? It means very specifically, especially those large language models, it means that you have a universal noise resilient templating or retemplating machine. That means that all the sort of steps for enterprise software, I'm talking into in the context of, I would say, workers as if white-collar workers in corporate environments. And it means that all the sort of steps that could not be automated in the past because we had to deal with text in any shape or form. That means read an email, extract a reference or price from an email or quantity, or categorize the type of complaint or request from a partner, supplier, client from an email. Identify if a product label is nonsensical. For example, if the product label is literally product description is missing. Okay, we have a problem. All those sort of things in the past could not be done easily. They could be done in other ways, but they could not be easily automated. If we had to go back, let's say, 5 years in the past, text mining was already a thing. It was already possible to have like text classifier and to do all sort of, I would say, to use all sort of natural language processing techniques, but they were costly. 2023 was a landmark because all those problems, due to the degree of packaging that was achieved with essentially GPT-4 serviced through an API, meant that all those NLP techniques, natural language processing technique, had their operational costs for companies slashed by a factor of 100, if not 1,000. Which means that, and not only the cost, but also the sort of time frame it takes to just set up the thing. And so the bottom line, and that's my prediction, is that a lot of support functions, I would say a lot of functions in the companies that are just internal function, that takes somehow data in, produce an output for the other divisions, will be automated. Supply chain is on the front line because it is not exactly a customer-facing function. It is very much an internal function, important one, but internal. And so the gist of it was LLMs were the missing brick to largely automated end-to-end the vast majority of mundane operation in supply chains. Lokad have been automating the quantitative analysis and quantitative decision-making process for a decade, but there are a lot of mundane operations that comes before and a lot of mundane operations that comes after. And that's the one that can be automated thanks to LLMs, those large language models.
And quickly and cheaply.
Exactly, quickly and cheaply, absolutely.
Well, thank you. And we do already have a video where we talk for, I think, about an hour and a half on that topic, so I won't dedicate any more of today to that, but that sets the table for the rest of the conversation. I kindly invite anyone who wants to hear more on that to review the previous video. Now, on that note, AI pilots, how do they fit into everything that you just said? What are they? What do they do in reality?
So, AI is, generally speaking, has been used consistently for the last 2 decades by vendors as a catchphrase, an umbrella terms to throw what they had. So Lokad, so when I say AI pilots, it's very much an offering of Lokad. It's an evolution of our offering. It's probably the biggest we had in years. And what is the difference? Well, the difference is an AI pilot is something is a piece of software, what we call a series of numerical recipes that not only execute the decision-making process, so that's the pure, I would say, the pure quantitative aspect of supply chain. So that's literally figuring exactly how much to order, where to allocate the stock, if you have to move the prices up or down, exactly how to schedule exactly the production with all the steps, etc. So that we were already doing, plus everything that comes before and after in terms of minutiae, mundane, clerical tasks that are mostly master data management prior to the data analysis, and then execution of the decision, which may involve, I would say, unstructured channels, like emails, for example, where you want to send an email to a supplier to request something to be expedited, or on the contrary, to an order to be postponed. And the gist of this offering is obviously LLMs that Lokad did not invent, that we have been extensively using for 14 months, a little bit more than that now. And the key insight in the way Lokad operate is that it should be one supply chain scientist that is able to take, I would say, full ownership of an initiative. For very large companies, we may have several people on the case, but unlike most of our competitors, they are typically not specialized. So it's not like we take a team of 3 with Mr. Database, Mr. Algorithms, and Mr. UI and UX user experience. That's absolutely not the way Lokad operates. A supply chain scientist is able to do everything from start to finish. And that's one of the reasons why Lokad has engineered the technology, its own technology, the way it does, and we have our own programming language, a domain-specific programming language named Envision, dedicated to the predictive optimization of supply chains. It may sound very weird to have come up with, a bespoke programming language, but the gist of it is, and that's a decision I took back in 2012, that we really needed something that was unified, so that one person could do the whole thing start to finish. Up to a few years ago, that was really get the raw transaction data from the ERPs, CRMs, EDI, and all those transactional systems. Complete that with an array of spreadsheets for all the structured data that unfortunately are part of the shadow IT rather than the regular IT, and then craft the decision making numerical recipes. And that was the responsibility of the supply chain scientist to do all of that. then to craft all the instrumentation, including dashboards and sort of reports, to make sure to convince himself or herself that the numbers were correct, but also to reassure our own clients about the validity of what we are doing. Plus all the instruments to monitor the quality of the data and then monitor over time the quality of the decisions. Plus, I would say, the plumbing to get the data out of the systems, but also re-inject the decisions into the systems as well. So that was, I would say, the scope that Lokad had. And there was two things that we couldn't really do. First, we had to be the recipient of the data. We couldn't really hunt for the data. And when I say hunt, the supply chain scientists could request data. We were not asking IT divisions or from our own clients to do any kind of fancy transformation that was just dumping the tables, pretty much, select star from table, bam. You do that once a day and you're done. So that was just super simple extracts, but still it was pretty much the IT division of our clients that was doing that. The supply chain scientists were not expected to hunt in the applicative landscape of our clients the data that the initiative needed. The reason for that was very simple. There is about 20-something SQL dialects out there. So Oracle SQL, Microsoft SQL Server, T-SQL dialect, MySQL, PostgreSQL, etc., etc. So there is something like 20 DB2 from IBM. There is 20 SQL dialects. So up to, again, a few years ago, a supply chain scientist would have struggled immensely just because even if what this person wanted to accomplish was extremely straightforward, like just dump a single table, the problem was this person would have spent literally tens of hours searching online to compose trivial queries. And whenever there was an error message, it would have been, again, this person, even if this person was generally familiar with SQL databases in general, it was, I would say, a massive hurdle to deal with dialects of systems that you didn't know. 2023, ChatGPT, the problem is solved. So ChatGPT as an assistant programmer is not necessarily super great to let you compose sophisticated apps. But when it comes to compose super simple SQL queries in dozens of dialects, it's super fast. And and again, the idea is that how you can avoid all these sort of hallucination problem. It's just a supply chain scientist is going to request a SQL query to be composed. This person is also intelligent and will proofread the query to make sure that it reflects the intent. It's just about removing the hurdle of discovering the syntax. But once you have the correct syntax that is presented to you, it's pretty much self-explanatory. So it's not very difficult. And thus, so that's and same thing if you have to access various systems, there might be tricks. I would say all sort of gotchas. And again, ChatGPT is excellent. If you want to test it out for yourself, just ask ChatGPT to give you a walkthrough to set up, Git on your machine and set up a Git repository or whatever. You will see what sort of super high quality answer you can get. And that's really a game changer, because that means that suddenly Lokad, who is training, supply chain scientists, we can take the responsibility of hunting the data. And I know that we have, through essentially ChatGPT, we have the tooling so that we don't overcommit ourselves in saying that we are going to hunt for the data. So that's I would say, one block of commitment where it's a game changer. Instead of asking IT to send us the data, we can just have an IP address whitelisted and then have like a very secure cloud-to-cloud connection, internet connection, and then let the team of supply chain scientists of Lokad chase their own data. And why does that make such a difference? Well, the reality is that even if Lokad only needs, for a given initiative, it's only about days of work for the IT. We're talking of maybe 10, 20 days of work even for a sizable initiative to get the 20 to 50 tables that we need. It's not, again, that's just dumping the table. No crossing, no joins, no fancy filtering. It is very, very straightforward. Still, the problem is that many of our clients have their own IT divisions that have huge backlogs. I mean, literally years of backlogs. And when you have like 3 years of backlog, even if Lokad is only asking for 10 days, it's 10 days plus 3 years of backlog. So even if we are not exactly put at the very end of the queue, if we are just in the middle of the queue, those 10 days of work from the IT may take anywhere like a year to get done. And that was, I would say, a frustration that we had, is that the majority of the delays that we are getting was from IT not being incompetent, not being slow, not even being slow. It's just that they had so much backlog that it was very, very difficult for them to allocate those 10 days. So here we are talking of something where instead of requesting 10, 20 days of work, we are talking of something like maybe less than a day of work, something like just a couple of hours, just to open a very secure, tight access read-only to the few systems that we need. And then the supply chain scientists themselves are going to survey the table, set up the data extractions logic, and make sure that the data extractions are really, I would say, light touch. The way we can do that, it's typically by monitoring the performance. Whenever the performance of the database drops, it means that there is a lot going on the database, and thus you typically want to relieve the pressure and delay your own data retrieval process. Because typically Lokad, we need to refresh the data on a daily basis, but it's not like super urgent. I mean, again, it depends. There are some situations where we have like really tight schedules, but very frequently, as far as supply chains is concerned, if we delay the retrieval from 30 minutes just because there is like a spike of activity on this database right now, it's a non-issue. So that would be first block of commitment is chase the data ourselves and thus eliminate the number one cause of delay, and vastly, I would say, accelerate the initiatives. Again, those delays were very frequently becoming like the bulk of the delay for the whole Lokad initiative to go to production was just waiting for IT to be able to allocate those days. The second block of commitments is master data improvement. And here, again, in the past, when you're facing a catalog where there is, let's say, 100,000 products description, some of them are garbage, maybe 1%. It is a lot of work to go through those 100,000 references, identify the descriptions or product labels that are incorrect, or sometimes it can be just a price point that is just completely inconsistent with the description. If it says a screw and the price point is $20,000, it's probably not just a screw. It's probably something else, etc. So there was a lot of I would say, basic sanity checks where, well, it seems like obvious and simple, but it was very difficult to automate that. And there was frequently no alternative but just to have a person screen the entries to look for just things that were really, really bad. And again, that's the sort of things where you nowadays with an LLM and potentially an LLM that is able to digest images as well, you can do a lot of things when it comes to surveying, monitor, and improve everything that is like master data related. In the specific case of Lokad, the master data part that is needed for piloting the supply chains.
Okay, well, there was a lot there. Thank you. I have a lot of questions that I want to follow up on. I am going to take a slight step back because if I can collapse all that down, you're describing, and correct me where I'm wrong, one supply chain scientist with access to one good LLM can do a tremendous amount of work that heretofore, or up until this moment, would have been passed along to, would have taken a lot of time and would have involved many, many, many people. Now, in a non-Lokad style setup, fill in the blanks. How many more people will be involved there? How many more fingers in the pies would there be? And then you can speak to the efficiency of it. But just in terms of the head count, what's the difference between supply chain scientists and LLM and, I don't know, s&op, for example?
Yeah, I mean, our clients are typically baffled by the fact that even a large initiative, it's like 2, 3 people and always the same. So, and we have Lokad, I'm very proud that Lokad, as an employer, we managed to keep people for quite a while, and so the bottom line is that Lokad is typically 1% start to finish. If we have several people, it is again to have redundancy, to have people, one day you focus on this part of the pipeline, and I do this other part of the pipeline, and the next day we switch. So you see, it is not like the people don't specialize. Each person, when we add people, each person has pretty much a competency across the entire pipeline. Again, there are some variations, and some people have, I would say, some particular specialty, but still, on the whole, it is people can really substitute for another. Our competitors, it's very different. Even a small initiative involved literally half a dozen people. You will have the project manager that is just there to coordinate the other guys. Then you have the consultant, you will have the UX designer, the configurator, the database administrator, the network specialist, etc. I mean, plus potentially a programmer, an actual software engineers for the customization that are non-native. Again, Lokad is a programmatic platform. Most of our competitors, their platforms are not programmatic. So whenever you want to have something that is like a programmatic behavior, you need to have a full-fledged software engineer that will literally implement with a general purpose programming language like Java or Python, the missing bits. So Lokad is really not like that. So I would say our competitors, pretty much by default, it's a dozen. S&op's initiatives may involve, several dozens of people, but it's not necessarily that many different skills. It's mostly different people from different departments, and very frequently it's not very much IT driven. So Lokad would be, when I say 1% versus half a dozen, I compare that to our competitors who are selling, APS, advanced planning system, or this sort of or inventory optimization system, this sort of pieces of enterprise software.
Okay. Well, thank you. And to come back to another point that you mentioned at the start, when you talked about the supply chain scientist, you gave the example of different SQL dialects, and then the supply chain scientist who may or may not be fluent in that specific client dialect would validate or monitor the scripts that were automatically generated because LLMs occasionally will hallucinate. Well, to that point, I mean, LLMs do hallucinate. I mean, very, very often. Now, again, it's improving, but you can ask an LLM with a piece of text, find this word hidden, can you see it? And it will say yes. Well, it's not there. I know it's not there. You know it's not there. How, at scale, can you have security and monitor quality control when you're talking about leveraging LLMs in an automated fashion?
So, first, hallucinations, are or confabulation. I prefer the term confabulation. They really happen when you use the LLM as like, I would say, a knowledge base of everything. So if you are using the LLMs like a knowledge base of everything, then it does happen. If you ask for papers of, let's say, medical papers and say, oh, give me a list of papers about this pathology or this pathology, it's going to give you something that is directionally correct. The authors are frequently, they exist.
They've published before.
They have published stuff that were in this area. They have published papers that were kind of in the same vein, but not quite. That's, again, think of it as if you were asking, a scientist to, on top of their head, remember stuff.
That's a nice analogy.
It's very difficult, you would say, and if you say you have to do it, they would probably come up with something that is halfway plausible with correct names of colleagues or researchers, correct, semi-correct titles. That's the sort of things. So that's a situation where you get, those confabulations, but you're kind of begging for it. I mean, you're asking the LLMs to behave like a database of everything. So it's very difficult. You're going to have this sort of problem. Same thing with SQL dialects. You try that and you get something. This thing will be approximately correct. If you ask, I want to read a table, it's going to do a select star from table this and that. It's never going to give you, when you ask for, let's say with GPT-4, when you ask to read a table, it's not going to give you drop table. It may give you a syntax that is slightly inadequate. So you test your SQL query and you have an error message and you do a small tweak and it works. But you see, it's still directionally correct. If you ask to read the database, it's not going to produce a command that delete a table or modify the permission rates of the database. Same thing when you ask to made up knowledge. For example, if you ask, okay, I have an industrial compressor of 20 kilowatt of power. Okay, what is the price point of that? If you ask ChatGPT, it may say probably something like $10,000. It's just guesstimating something. This is literally made up. It is plausible, but is it correct? Probably not. And it depends on hundreds of variants because there is so many different compressors for various situations. So the bottom line is that confabulations do not happen at random. There is really specific sort of task where they happen much more frequently. So I would say when you're begging for it, so when you're using the LLM like a mock database or a database of everything, then it's better to double check. It can be extremely useful. It gives you, for example, for the SQL dialects, it will give you hint about the sort of keywords that you should use, what the syntax look like, and it may make a small mistake, miss a comma or something, but with a few iterations, you will get it right, especially because once you have the SQL query, you can actually test it on the database, you will see the output, and you will validate. So you have like a feedback loop that is instant to validate that. If you want to detect, let's say, weird product labels, product labels that looks like fishy, like this product description is missing. That's your product label. Okay, that's obviously wrong. But you can have all sorts of wrong. For example, you can have a product label that say tournevis cruciforme. It's like, and it's in French. And so the problem is that it's just in French. It's a screwdriver with, I'm not sure in English, with a, yes, Phillips head.
I think, pretty sure.
And so, again, you can ask for things, but at some point, it's not perfect. It's a judgment call. A human would make mistakes just the same. So you cannot expect the LLM to be, I would say, an endgame oracle that is able to answer every question right. At some point, if you're doing a task such as reviewing the 100,000 products of your catalog for anomalies in labels, the LLM will have false positive and false negative, just like a human. But the interesting thing is that you can actually measure the rate of false positive and false negatives and then decide whether it is worth it or not. And very frequently, you get something that is quite good. So that's literally out of the box, something that gives you a lot of value, even if it still does some mistake. Again,
well, progress, progress, not perfection.
Exactly. I mean, if you can reduce by 90% your master data problems with something that is very, very cheap and that can be re-executed within literally hours unattended, that's very, very good.
There's also then the value add of the time that was not spent doing that manually, that you might have done something else that generates or adds value. So again, there are direct and indirect drivers there of value.
Yeah. Plus the reality is that when you do a super repetitive task for 1 hour, you can have a certain degree of quality. When you do that for 100 hours, the hour 67, I mean, you typically humans are not, I would say, constant performance engines. After a few hours, you would just the concentration would drop, and so the amount of false positive, false negative would probably skyrocket, even with a fairly diligent employee.
Well, thank you, and I want to be mindful of the fact that we do actually have some questions from the audience that actually address things I was going to ask. So I will skip some things, but they will be addressed in the audience questions. But one final thought here. When you talk about the supply chain scientist, the AI pilot, and we'll come back to that later in the questions, but the supply chain scientist, an AI pilot, and the client, how does that orchestration actually work on a day-to-day basis? Like, does the client have access to, do they interact with the LLM?
So the typical way we see it is that all the numerical recipes composed by supply chain scientists are the AI pilot. This is the thing that pilots the supply chain on a daily basis. It's unattended. It generates the decisions. And now with LLMs, it does the minutiae of the data preparation. And it does, I would say, the post-decisions minutiae as well.
For example there.
The minutiae for the, I would say, pre-decision would be ask suppliers for their MOQs. You need to fetch this information, it's missing or it's not up to date. You need to chase that. LMs can help you to get that. And post-decision, that will be send an email to ask for an ETA, estimated time of arrival, for orders if you don't have an EDI in place, or if you don't have a bridge, or ask for to expedite an order or postpone. That's the sort of, again, minutiae that comes afterward, where Lokad can generate the decision to request to expedite an order, but not do the minutiae, which was just compose an email and send it. So all of that is pretty much the AI pilot, and that's a big numerical recipe that does the process end to end. All of that is implemented by the supply chain scientist. So this is an extension of scope for Lokad. The supply chain scientist is the co-pilot, actually. And really think of it as, when I say pilot, I really mean like an automated pilot in an aircraft. And by the way, aircraft nowadays, the most difficult maneuvers are done on autopilot. When you have like very, very scary airports, like the legacy airport of Hong Kong, they have a new one that is much easier, but they have one that is literally in the middle of high-rise buildings. Then the autopilot for those maneuvers is mandatory. So it's done. It's the machine all the way. People just monitor. So here, the supply chain scientist is engineering the numerical recipes, and they are the co-pilot. They decide. They do pretty much the navigation, to direct the things, and then they engineer the plan and the course plan for the AI pilot. But fundamentally, the supply chain scientist is playing the role of the co-pilot. figuring the directions, thinking ahead, and making sure that the pilot can operate as smoothly as possible. But fundamentally, all the high frequency adjustments, it is the pilot, not the copilot. And then the client would be the role of the captain. But a bit like in the old TV series, Star Trek, where there's the captain sitting on the chair and giving the super high level instruction to the crew. So the client in this setup is giving the strategy and giving the overall directions. Then it is the role of the supply chain scientist to implement that, and the role of the pilot is just to execute all the micro adjustments that are needed, or all the daily decisions that are needed for supply chain, and then execute the supply chain per se.
And this is also, again, just to be clear, because we didn't talk about it, but that is in addition to all the automated quantitative tasks that are already done. They've been done for years. So in case anyone's listening and thinking, oh, well, that's just a qualitative task. We're talking about end-to-end quantitative, like the factoring of economic drivers, generating, allocation, purchasing, pricing. That's also AI-driven already and automated.
Yes.
So the supply chain scientist is overseeing both of these sort of consoles, the quantitative and qualitative.
Exactly. And the reason why Lokad, started to embrace this AI keyword at last, that's an umbrella term, was because we are now throwing to the mix LLMs. And so, we already had machine learning with differentiable programming, and stochastic optimization, but now we are throwing, I would say, LLMs on top. And so that's literally a very, very complete toolkit. And the effect is literally for clients, supply chains that can run unattended for weeks. Again, people are surprised for how long, when you have those economic drivers, you can actually operate fully unattended. That the beauty of it is that you don't need to do any kind of micro adjustments. For example, adjustment to the forecast are, for most of our clients, completely non-existent. And most of the other adjustments are also done completely automatically, such as introduction of new products, phase out of old products, introduction of new suppliers, and phase out of non-performing suppliers. So all of that is kind of business as usual. And when the recipes are done correctly, they require, already in the past, they didn't require that many interventions. But with this AI pilot that includes LLMs, adding a new supplier into the mix, all these sort of things can be even less manual intervention than it used to be.
Okay, well, Joannes, thank you. We've been going for about 40 minutes. There are questions to get to, so I will push us towards that now. But before we do, as a sort of like a summary or a closing thought, again, in the context of the much larger conversation that we were having, that we had a month ago, and now that we're having today, what's the bottom line for both the supply chain practitioner and, let's say, the executive teams who oversee the average, the normal supply chain practitioner? Right now, what's the call to action or takeaway for them?
I believe that a decade from now, this vision of AI pilots, maybe under a different name, will be the norm. Maybe it will be the norm, and so people would just say supply chain and not AI pilots for supply chain. It will be kind of obvious that supply chain is, you have those AI pilots, just like when you say a computer, you don't say, I have a CPU, I have memory, and whatnot. It's a given that you have a CPU in your computer, so you don't even mention that. So my take is that something like a decade from now, it will be, those functions will be extensively automated. And Lokad, with those AI pilots, it's a package offering that just do it with supply chain scientists. For our clients, it means that the supply chain practice changes in nature. It means that they have those AI pilots that can liberate the bandwidth, a lot of it. And we were already liberating the bandwidth for the decision-making process or the complex calculation. But now we also liberate the time that was just, monitoring all the time the list of SKUs, the list of suppliers, the list of clients, just to keep the master data correct and clean and sane. All of that is also going away, and remove all the need to have those manual interventions that were very frequently not even really quantitative in nature. You had to fix a label, fix an entry, remove a duplicate or something. All of that, again, Lokad, we take care of that. And so the bottom line is that it's a massive, productivity improvements. I think we are, with some clients, we are literally achieving this 90%, 90% reductions in terms of headcount for the previous functions. The reality is that the task, exactly. Now you have more time and you can actually do, which is the things that are much more difficult to automate. And I believe that adds more value, which is really think carefully about the strategy, spend a lot more time to think about the options, what should you be exploring, instead of, again, wasting your time on spreadsheets. So spend a lot of time thinking long and hard about the difficult problems, and then talk to suppliers and talk to clients. And to have like genuine, in-depth conversations so that you can organize your own supply chain to make your supplier happy, and thus they will be willing to give you better prices, you will have better quality, better reliability, etc. If you organize yourself to suit the need of your suppliers, it may sound a little bit the opposite, where, suppliers, I am the client, they have to accommodate me. But if you can accommodate your suppliers better, it's a team effort, and you can have, more reliability and better prices. And you can do the same effort with your client because there is the same collaboration that should happen. And again, it takes a lot of intelligent discussion, and that's the sort of things where it is, I would say, beyond what those LLMs can deliver nowadays. So I believe that Lokad, we can automate the tasks that were like low value, minutiae and mundane clerical tasks, and have people do the high-level semi-strategic thing. I say semi-strategic because you will talk to one client at a time, etc. And then do the strategy, which is summarize all of that, create a vision, and then support the supply chain leadership so that they have like a very clear, I would say, well-founded strategy for the company.
So again, just to take two examples, just to conceptualize that, like the low-level decisions going through Excel spreadsheet, saying, it says block in colors, it must mean black, like you're auto-correcting that. That's trivial, it's mundane, It's not worth your time.
Yes.
Should I open a warehouse in Hamburg? Strategic.
Yes, it's strategic, plus the problem is that there are so many options. You could say, a warehouse, should I buy, should I rent, what sort of contracts, what is the degree of mechanization? Do I need to have a contract for the equipment so that I can give it back? Should I lease the equipment or not? I mean, there is like hundreds of questions. And very frequently, all those questions are, again, when people have to spend 99% of their mental bandwidth on the clerical tasks, they don't have any time left to spend on those big questions. And you see, that's a variant of the Parkinson laws. People would say, I've seen many companies where if I were to compute the sum total of minutes spent on something, ABC class, the time would be every year. We are talking of man-years invested into ABC classes. And when it comes to decide for a new warehouse, we are talking of weeks of time. But you see the imbalance where people spend literally collectively years of human time for something that is completely nonsensical, like ABC classes. And when it comes to the 50 million euro investment to open a warehouse, then it is literally weeks of time and then bam, a decision. You see, that's the sort of thing. It should be the other way around.
All right. Well, Joannes, thank you. On that note, I will switch over to the audience questions. Thank you very much. Feel free to submit them up until basically I stop. Well, first, so Joannes, this is from Massimo. Could you elaborate, please, on how IT can leverage AI pilots to reduce backlog and why you believe this approach should be proposed?
So, AI pilots is not about reducing the backlogs of IT. It is about coping with the fact that IT has years of backlog. So our plan at Lokad, reducing the backlog of IT requires to rethink IT the way Amazon did. That would be another episode. So I would say look for the 2002 memo of Jeff Bezos concerning the APIs at Amazon. The bottom line is that all the departments in a modern company needs tons of software stuff. Every single division, marketing, finance, accounting, supply chain, you name it, sales, they all want tons of software tools. And IT is, all of that fall onto the shoulders of IT. IT is collapsing under that. So my point is that Lokad, we are supply chain specialists. We are not going to address all the things for marketing, sales, accounting, and whatnot. What we say is that with LLMs, we can liberate IT from taking care of Lokad. So bottom line is that we go from needing, let's say, 10 to 20 days of work from IT to get the quantitative supply chain initiative, up and running.
Building the pipeline, essentially.
Building the pipeline.
Yeah.
To just a few hours. So we are not solving the backlog. IT does what IT does. They can also benefit from LLMs, but in their case, the situations are much more diverse, much more difficult. So my proposition is not that LLMs can actually help IT to slash their backlogs. It's just a way for Lokad, in the specific case, to say, well, instead of adding 20 more days to the backlog, we just add something like 4 hours and we are done. And so that's it. Okay. That's how we cope with the backlog. And then more generally, the solution to those years of backlog is that every single division need to re-internalize most of the software stuff. You see, the years of backlog is that companies overall are demanding too much from IT. You should have, I would say, digital practices in every division, marketing, sales, accounting, and whatnot. You should not ask IT to solve all those problems for you. It should have, digital experts in every area to do that. And that's exactly the essence of this memo of 2002, if I don't confabulate, of Jeff Bezos to his team. It's a very famous memo. You could type famous memo Bezos, because he was saying, in essence, you have 2 weeks to have a plan to be able to, every division, to expose all your data, so that we don't have this sort of siloing and sort of power games being played in the company in Amazon. And Bezos was concluding, every single manager that doesn't have a plan on my desk 2 weeks from now is fired or something.
Okay. Well, thank you. This next comment, and it's a question I deliberately didn't ask because I saw that it was mentioned in the comments, so it's phrased as a comment, but take it as a question. This is from Jesse. One supply chain scientist plus one LLM still sounds like a co-pilot. So again, delineate AI pilot v co-pilot.
So again, for me, the reason why we say it's a pilot, it's literally we have some clients where for weeks, all the decisions are generated and then executed unattended. And when I say unattended, I really mean it. During the lockdowns of 2020, we even had a company that where for 14 months, all the white collars were literally stay at home, don't work, paid by the state, because state was giving subsidies in Europe, several states were giving subsidies to essentially stay at home and don't work.
We remember.
And so that was the situation. So we had that. And when you have a supply chain that operates, pretty much unattended for 14 months, yeah, I call it a pilot, not a co-pilot. Again, if there is nobody to supervise the numbers generated by the system, I really think it's a pilot.
But we weren't using an LLM back then, so
no,
it's not apples to apples.
And it was a situations where the data was clean and there was no dramatic need to do this master data management, and that was a client that had very high maturity in terms of EDI integration and whatnot. So the sort of things that were needed before and after were very, very limited anyway. Back to the question of the copilot. Most of the competitors of Lokad are saying that they are doing copilot. And indeed, the way they do it, and this is a completely different thing. Lokad, the supply chain scientist, is using a programming language. So when we're using an LLM, it is to help us generate pieces of a program. That's what we're using it for. So the LLM is used to generate essentially pieces of programs. That can be the SQL dialects, that can be a few other things. And then we engineer the pilot, and then the pilot runs unattended. Our competitors, especially those who are saying they are going to bring conversational AI, UI, user interface, to the market, they do something completely differently. Completely different. What they do is typically RAG, retrieval augmented generation. So what they do is that they compose a prompt. They will. That's literally all our competitors that says that they do AI with LLM right now in the supply chain space. They compose, let's say, a dozen prompts fitting various scenarios. Then after the prompt, they inject data retrieved from the database. That can be basic descriptive statistics. So they would inject a few dozen numbers, average sales over last week, last month, last year, or whatever. Basic statistics that fit the scenario. And then they would add the extra query from the user, and then the LLM will complete the answer. You see, so this is, again, LLMs are just about text completion. So you compose the text and it completes. And retrieval augmented generation, the retrieval part is just retrieval some numbers from the database and then compose. But the bottom line is that, okay, now you get something where you can ask question, but the reality is that if you're not clueless, you can read the numbers directly from the screen. There is no magic. So the LLM just sees the numbers just like you can see them on your report. So fundamentally, it can only answer questions that are readily answered by a dashboard. So yes, if you're not really familiar with the definition of every number, it can clarify that for you, but you can also have, that's the way Lokad does it, have like a cheat sheet that just gives you, the one-liner description attached to every dashboard for every number that is present on the dashboard, and that will effectively do the exact same role, no AI involved. So bottom line, I'm very, very skeptical of those conversational AI, those copilots, because essentially they are gimmicks that are overlaid on top of existing systems that have never been designed for any kind of machine learning system, not even not even the classic sort of machine learning, let alone LLMs. So that's why I say, to my knowledge, all my competitors are doing copilots where essentially they have something that is, let's say, a chatbot that is on top dashboards, but it doesn't do any automation. It doesn't, let you automate any kind of AI pilots. It is, a gimmick on top of a legacy system.
Okay, well, thank you. I'll push on. This is from Kyle. Can you please discuss the criticality of process analysis before instituting an AI model? I'll take it as a supply chain context.
As surprising as it may be, the process analysis, I mean, it's very important, but not necessarily in the ways that people think it is. The reality is that, especially in supply chains, companies had 4-5 decades to invent tons of made-up processes. And I say made-up intentionally, where supply chain is, I mean, it comes, we have an episode on that, with a bureaucratic core. You know, it is supply chain, the game of supply chain for the last 5 decades has been, you know, a way to organize the labor, because you cannot have one person that deal with all the SKUs, all the warehouse, all the locations, all the products. So you need to divide and conquer, you know, the problem, spreading the workload over dozens, possibly hundreds of people for very large companies. So you end up having a situation where 99%, not 99, let's say 90% of your processes just reflect the emergent complications that you have due to the fact that the workload is spread over a lot of people. So you see, it is accidental processes, not essential processes. So I would say, yes, you need to do the process analysis, but beware. 90% of the existing processes are not addressing the fundamental problem that your supply chain face, but accidental problems created by the fact that you need a lot of people to solve the 10% of the problem that needs to be addressed. So if we take, let's say, a very complicated industry, let's say chemical processing, where you have like a lot of flows, a lot of dependencies. Whenever you have like a chemical reactions, you're going to have like byproducts. And so whenever you produce a compound, or you're going to produce something else, this something else can be sold or used for another process. Oh, such a headache. It's very complicated. You need to coordinate all of that. You have tons of constraints. You have tons of process that operate through batches. You have process that operate continuously. So it's very, very complicated. But the reality is that most of the processes, instead of focusing on the physicality of the problem, the fact that, let's say, you have like a process industry, you have chemical reactions that have very specific, you know, inputs and output, and all of that is very, very clearly defined and known. Instead of focusing on, you know, the base layer of the physical reality of your business, the process analysis might just reverse engineer process that will be gone when you set up the AI pilot. You see, the interesting thing is that when you do it AI pilot style, you don't need anymore this divide and conquer approach. You know, it is a unified set of numerical recipe that solve the problem end to end. So all those coordination problems that were solved by as many processes are just gone. And so literally my experience is that 90% of those processes are just going to be gone by the time we are finished. So that's why I say, yes, it's very important as long as you keep, I would say, a razor sharp focus on the base physical layer of your supply chain as opposed to the sort of made-up processes that are just there to coordinate numerous teams, because those things are not going to be upgraded. They are going to be replaced by the AI pilot.
Thank you. And actually, an example that you listed in that answer provides a nice segue here. So from, forgive me if I'm not pronouncing this correctly, Dervesh, do you have plans to open source Envision for educational or small business use? And can it be programmed with rules to benefit B2B businesses like chemicals that require extensive manual input?
So yes, we have plans to open source at some point Envision. So let me first give you the explanation why. So first, Envision, I mean, let's be clear. In this world of enterprise software, we have public documentation for Envision. So we have a language. Most of my peers have DSLs, but they are not publicly documented. Dassault Systems has purchased another company called Quintic at the time. It comes with a DSL. it is not documented publicly. So there is literally in the supply chain space other companies that have DSLs and they are not public. So Lokad, we document everything publicly, and we have a free sandbox environment, a playground environment for Envision, and we even have free workshops that are made available so that you can actually teach Envision or learn Envisions with exercise and whatnot. So we are doing, I would say, a lot more. Now, when it comes to open sourcing a language, it is part of the plan, but it is too soon. Why? Because Envision is still under rapid evolution. You see, one of the problems that you have when you open source a compiler, the compiler is a piece of software program that let compile your script into something that executes. As soon as you open source your compiler, it means that people are going to operate Envision code, in the case of Lokad, in the wild, and Lokad lose the possibility to upgrade automatically those scripts. The reality is that during the last decades, Lokad has modified hundreds of times the Envision programming language. This language is not stable. If you look at the quantitative supply chain book, that is now something like 6 years old, the syntax of Envision has evolved dramatically. You can have like a peak at, I would say, vestigial syntax that do not exist anymore in Envision. And so how do we deal with this constant change of syntax? Well, every week, Lokad, we do have like weekly releases on Tuesdays. And what we apply is we apply automated rewrites for all the Envision scripts that are operated on the Lokad platforms. So it is one of the key properties of Envision is to be very, I would say, to have a very high affinity to static analysis. And static analysis is, by the way, a branch of language design and language analysis. When I say language, I mean computer language. That lets you have like properties of programs without running them. And through static analysis, what we can do is literally rewrite automatically an existing script from the old syntax to the new syntax. And we do that automatically on Tuesday. And typically when we do an upgrade, we will have, for a few days, we'll have the old syntax and the new syntax that are both accepted. We do the automated rewrites. And then when we see that the ancient syntax do not exist anymore, we, with a feature flag, we lock in the fact that only the new syntax exists. And Lokad, we have already deployed over 200 of those automated rewrites. It's typically, we do it like, we release every Tuesdays, but typically we have like 2 rewrites a month or so. And we have been doing that for a decade. So as long as this process is going on, Lokad, we cannot realistically release Envision as open source. It will come in due time, but I don't want to repeat the massive blunder of Python. Yeah. The upgrade from Python 2 to Python 3 took the Python community a decade, and it was so incredibly painful. I mean, companies went into years of upgrade. It was a nightmare that lasted for a decade. So that was really, really wrong. Even Microsoft with the upgrade from C#, it's not just Python, and C# with the upgrade from .NET framework to .NET Core took half a decade. And that was a big, big pain. So that's again the problem of once you have a compiler that is open source in the wild, you do not control the code. So if you want to bring changes to the language, you need to collaborate with your community. It makes the process super slow, super painful. And in the end, you never really eliminate all the bad feature of your language. If we look at Python, the way, for example, object-oriented programming was introduced in Python, the syntax, it's clunky. It's really, you can feel that Python was not designed with object-oriented programming in mind. It was a later addition in the late 90s, and the syntax is kind of crap, and now it's there forever. And by the way, every single language has that. C#, you have the keyword volatile that serve no purpose anymore. C++ is stuck forever with multiple inheritance. That was a mistake. Having multiple inheritance, it was a bad design decision that complicates everything, etc., etc., etc. The only way to be able to avoid those big mistakes, Lokad, we did a lot of big mistakes in the design of Envisions, but we fixed them after one. And we're still in the process, especially when we have like new paradigms coming in. For example, differentiable programming was like a big new paradigm, and we had to re-engineer the language itself to accommodate this paradigm. By the way, there is like a major mega proposal for Swift proposed by Apple to do like to make differentiable programming a first-class citizen in Swift. But it's probably not going to happen anytime soon. It is like a major, major revamp. Right now, the language that is the closest to having differentiable programming as a first-class citizen would be Julia. And even there, it is a lot of duct tape.
Okay, thank you. Again, still 3 more to get through. Next one is from Victor. Again, this is broadly about AI. How does AI address random bottlenecks, given that it operates on large data sets to predict plausible scenarios or recurring issues?
So, I mean, first, let's be clear when we say about AI.
Yeah.
It's a collection of techniques.
Yeah.
So, Lokad, what we have is typically LLMs, and then we have differentiable programming, and then we have stochastic optimization. Differentiable programming is about is for learning. Stochastic optimization is about to optimize under constraints in presence of uncertainty, the probabilistic models that are typically regressed with differentiable programming. And LLMs is to do this universal noise-resistant templating engine. That's pretty much the components we are looking at. So here in this question, when you approach, I would say, a probabilistic, when you approach supply chain with probabilistic tools, most of the sort of, I would say, tasks that are hinted by this question just go away. You know, that's the beauty of probabilistic forecast, is that it becomes a lot, those forecasts are not more accurate. They are just much more resilient to the ambient noise of the supply chain. And so they largely eliminate, when you couple probabilistic forecasting with stochastic optimization, you largely eliminate all the need for manual intervention. And when I say largely, I mean for most clients, it completely eliminates that. And now we are left with tasks that requires to go through text and to deal with that, and that's LLMs. And then, again, when I described is, look at, we have those AI pilots that are really automated. And if there is a manual intervention, it is not to do like to do a clerical entry in the system. It is to do to input a strategic revision of the numerical recipe that will typically be a profound modification of the logic itself to reflect the revised strategy. It's not going to be, you know, a minor thing. It's typically going to be something that is kind of fundamental and change the very structure of the logic that has been implemented.
Okay, thank you. 2 more. This one from Asan. Could you please explain how AI, again, you can take this to mean LLM or however you please. Could you explain how AI would expedite an order? Specifically, would it be able to execute transactions in the ERP system based on verbal commands?
So verbal commands is the wrong way to approach the problem. Again, you're not, if what you want is faster data entries, the voice is a very low bandwidth channel. So you type faster than you speak, unless you're very bad at typing. But so no, this is not the sort of gain that you can get. If your UI is correctly designed with a keyboard, you will be faster than voice command. By the way, I know that very well because 20 years ago I was working at AT&T Labs on AT&T Labs was on the forefront of production-grade voice recognition systems, and there were tons of applications where it didn't work out. You know, the voice recognition was working, but the reality is your hands on the keyboard were just faster. So typically the situation for voice was either dirty hands or busy hands. That was the two situations where verbal commands were okay, otherwise the keyboard is just faster. Okay, back to the question. So first, you want to filter the orders. So here we have a decision-making process where you want to decide which orders need to be expedited. Okay, so that's classic Lokad. So Lokad, that's a pure decision-making process, quantitative. You need to decide, yes or no, is this order that is ongoing warrant or request for to expedite the process. That's, you know, so Lokad, we would do that, and again, we would do that with differentiable programming and stochastic optimization. That would be the two key components. That's how we get to the correct decisions. And now, once we have that, we have automatically, every day, the decisions for the orders. So it's not about having someone that gives verbal orders for that. It's going to be part of the set of numerical recipes. We are going to compute the optimized orders. And then, as time goes on, we realize that some orders were, you know, overshooting or undershooting, and we will request to postpone or, you know, expedite respectively. And the part of the LLM is just about using this quantitative decision, you know, where you have like a binary flag that says, please expedite, to generate an email with a proper context, send it to the supplier with something like, please acknowledge that you can do, and then the supplier is going to acknowledge, hopefully, and say, yes, no, maybe I can, or this is what I can offer. And you have this chit-chat, and that's what the LLM will automate, the chit-chat with the supplier. You see, so that's the AI. It is not about deciding to expedite the order. That is a pure quantitative decision that needs to be approached with, I would say, quantitative tools, differentiable programming, stochastic optimization. The LLM is there for the interaction with the supplier, which frequently is going to use an unstructured channel like email.
Yeah.
And that's it. And again, if you're thinking about voice commands, it's not going to fly. It is way too slow. Been there, done that. Again, I was part of, I've had the privilege to work with the teams that literally brought to the market the first production-grade voice recognition systems 20 years ago. That was the AT&T Labs, former Bell Labs in the US, where I spent 2 years. But the bottom line is, no, you're not going to use, those AI technologies to do that. It's just that voice commands don't have the bandwidth to do what you want to do.
All right, thank you. And on a related note, when we talk about stochastic optimization and differentiable programming, we do have extensive video resources on those topics.
Yes.
So we're obviously not unpacking those because they are, I think there's a three-part series on differentiable programming, but we're not just ignoring those, but they've been covered. And I kindly direct viewers who want to learn more about that to review those and then piece together these pieces. They can rag it. Last question, and it is from Isaac. You can take a sip. It's actually a long question. So, as a customer currently learning Envision, I'm interested in its integration capabilities, specifically with GitHub. Could you discuss the potential for Envision to support GitHub integration, particularly for applications such as explaining code blocks in natural language or identifying changes between versions? Lastly, is there any plan to introduce an Envision Copilot in the near future? So a lot of, take your pick.
Yeah, a lot of questions.
Yeah.
So
Envision
yes.
GitHub.
So the short answer is yes, yes, and yes.
And yes.
The timeline it varies very much depending on the components we are talking of. So on using LLMs for to do essentially Copilot, to be like the GitHub Copilot, but that will be the Lokad Copilot on Envision code. We are already working on that. And the very interesting thing is that, again, due to the fact that it's a DSL where we control, we have complete control on the training materials. And that's very, very cool, because that means that the day we successfully manage to bring this LLM to production, whenever we change the syntax, we will rerun our training process with the updated syntax, and we will always have a copilot that gives you the up-to-date Envision syntax, as opposed to GitHub Copilot that gives you a Python syntax, a C# syntax, a Java syntax. Because you see, again, Java has been around for 25 years. Python have been around for more than 30 years. C# has been around for 22 years or something. So whenever you're asking GitHub Copilot to write code for you, the problem is that it gives you one flavor of semi-recent of those language, but not actually super recent. And sometimes you don't want the recent flavor because your environment, again, is not, I would say, in line with those super recent version that you don't support yet. So bottom line, yes, we are working on that. We are working on a whole series, the whole series of supernatural features such as comment my code, explain my code, complete my code. We are also thinking of a lot of extended code actions that are very specific to the sort of workflows that happen within Lokad. For example, we are working on being able to automate the generation of data health dashboards. That's a very typical task. So data health dashboards are essentially instruments that check that the data that we ingest is sane. And we have a lot of heuristics and know-how on what to check, because the sort of problems that you will find in data of ERPs, they are kind of always the same. So it's not so when we check data for correctness coming from an ERP, we supply chain scientists have cultivated literally we have our own training materials to know what to look for, and we have our own recipes, human recipes of what should I implement, why should I check, and we could largely automate that with LLMs. So this is something that is in progress at Lokad. So that would be GitHub Copilot. That would be the Lokad Copilot. Then to make Envision more friendly with GitHub, we have already released an open source Visual Studio Code extension. So the interesting thing is that you can already put Envision code into a Git repository, no problem. You just, by the way, the file extension is .nvn. So you just create a .nvn file and you commit and you're done. But if you want to edit the code with nice code coloring, you would need a Visual Studio Code extension. If you look for Lokad Visual Studio Code extension for Envision, there is one that is, by the way, this one is completely open source. And you will get code coloring so that you can have Visual Studio Code, code coloring, and commit that. In the future, we have, but we're not working on that yet, but we have the plan at some point to expose the code, the Envision code that sits into a Lokad account as a Git repository. The reality is that the way the Envision code is stored in a Lokad account is pretty much the same as a Git repository. It's versioned pretty much the same way. It is not organized exactly the same way as Git. Again, I'm not going to go too far into the technical reasons. Git is very much agnostic to the language. If you're only dealing with one language in particular, you can be smarter and do all sorts of things that are not possible in the general case. But the bottom line is that the Envision code is entirely versioned the way it is. And so it has like a nice affinity to a Git repository. So what we could do, and that's something we're considering, is expose a Git repository that let you, export all your code from a Lokad account to a Git repository, and maybe later the other way to have like a two-way synchronization. Git is a decentralized system where every Git repository is like the whole thing. You have like a complete copy, and so you can get changes from a remote repository, but send your changes to a remote repository. And so at some point we'll probably first introduce the export and then introduce the re-import, but that will take time. We are not there yet. It is, I would say, it is part of the roadmap, but we don't have any timeline for that yet.
True, and also it is worth pointing out that a few people in the comments did say that they were, again, learning Envision. We do produce a series of tutorials that are done in collaboration with, I think, University of Toronto right now.
Yes, plus
so again,
a few others.
That are in the pipeline. So there are free resources, and we can provide answers if people want. So yeah, for anyone who does, that was a lot about Envision. For anyone who wants to learn, our supply chain scientists put a lot of effort into those workshops, so they are freely available on our website.
And for those who are not interested in becoming, supply chain scientists themselves, Lokad can provide the supply chain scientist as part of those AI pilot offering.
It's true. All right. Well, that's all the questions. Joannes, thank you very much for your time, and thank you very much for watching. I hope it's been useful, and we'll see you next time.